Hi everybody, we are going to look at section 4.1 in our Hawkes textbook. It is on relations and functions. Alright, so the first thing we're going to talk about is what a relation is. And a relation is any set of ordered pairs. I'm just going to create, we'll do 2, 3. I'm going to create a set of ordered pairs. 5, 1, negative 6, 3, and 7, 8. All right, so this is a relation. It's a set of ordered pairs. Typically, we call them our XY coordinates. And these sets have special names. The domain of the relation is always the first coordinates, and the range is always the second set. So that means that my domain, in our case, when they ask for the domain, they are looking for the X values. So when we have a set of ordered pairs, my domain would be, and you write it with the brackets, 2, 5, negative 6, and 7. But it is typically when they ask for the domain, like if you're looking at a graph and they ask for the domain in the range, they are looking for the X values. The range is your second set in the coordinates, or they are talking about the Y values. So in our case, our Y values for this set of ordered pairs would be 3, 1. We already used 3. It's okay to have a repeat, but we're not going to write it in our set. And then 8. So that would be my range or my Y values. Okay. So for this first example, they give us a set of ordered pairs. Our ordered pairs are negative 4, 2, 6, negative 1, 0, 0, negative 4, 0, and then pi and pi squared. They want us to state the domain and the range. So again, remember your domain are your X values. So it's any X values that could be in the relation. So in this case, it is going to be, we have negative 4, we have 6, 0. Again, negative 4 is already listed, so I'm not going to list it twice. If it's in there twice, that's okay, but you don't have to write it twice. And then pi, and that's my domain. Your range is always the Y values. So in this case, our range is going to be 2, negative 1, 0. And again, 0 is listed twice. I'm only going to list it once. And then pi squared. And that will be my range. Again, domain, the important thing to remember, domain is whatever your X values could be, range, or whatever your Y values could be. So now we've talked about a relation, we're going to talk about a function. And a function is a relation in which every element of the domain is paired with exactly one element of the range. Equivalently, a function is a relation in which no two distinct ordered pairs have the same first coordinate. When they ask if you have a set of ordered pairs and they ask if your set of ordered pairs or your relation is a function, what the definition of a function is, every element in the domain, so every element in the domain or every X value is paired with exactly one element of the range, so one Y value. So if I made up a set of ordered pairs, so I'm going to make up a relation. Let's do negative 3, 2, negative 6, 7, 8, 2, and we'll do 5, 4. All right, so that is a relation that I made up. This is a relation. Now, they're going to ask me, the question you might see is this relation a function? And what you have to do is you have to look at your domain, so my domain, and I like to write it either horizontally or vertically, but I'm going to write it out. So my domain is negative 3, negative 6, 8, and 5. My range, put that in blue, is 2, 7, We already have the 2. I'm not going to list it again. And then 4. So in order for our relation to be a function, each element of the domain has to be paired with exactly one element of the range. So if I go and I look at my ordered pairs, I have -3 goes to 2, -6 goes to 7, 8 is paired with 2, and then 5 is paired with 4. Now, is this a function? Yes or no? The hard thing is we have 8 and -3 that both go to 2. But the definition of a function is each domain has exactly one y value. Each member of my domain only goes to one range. It doesn't matter that -3 and 8 both go to 2. That's okay. But every domain has to have only one y value. So this is a function. But if I if I created another relation, so let me make another relation, and I'm going to do -3, 2. I'm going to make it similar to the other one. -6, 7. We'll do 8, 2. And then I'm going to do -3, 5. So now for this one, my domain is -3, -6, and -8. And again, I only have to write -3 once because it's repeated. My range is 2, 7, and 5. Now, if I draw my lines, -3 goes to 2, 6 goes to 7, +8, sorry. 8 goes to 2, and then -3 goes to 5. Now, this is not a function. The reason it's not a function is because if you look at -3, it goes to 2 places. It goes to 2 and it goes to 5. Your x values can only go to 1 place. They can't go to 2. So this is not a function. Now, what I do, or the way I look at it, I look at this as your domain, your people, our people. Your range are different rooms. So I can have more than one person in a room or in my range. But if I'm one person, so if I'm -3, and I have to be in 2 places at once, I have to be in room 2 and room 5 at once, can I do that? No, we're not Harry Potter. We can't split ourselves in half. We can't send ourselves to 2 different places at once. So just think, your domain cannot have 2 different y values. It can only have one y value. It doesn't matter that if every number in the domain has the same y value, but all your domain values have to be different in order for your relation to be a function. Now, not all relations are going to be given to us as a set of ordered pairs. Sometimes they're going to be graphed, and they're going to ask you if that graph is a function. So in order for a relation to be a function, if it is graphed and you want to check it out, you are going to use the vertical line test, and you have to make sure that the vertical line passes through the graph no more than once. If even one vertical line intersects the graph at 2 or more times, then the relation fails to be a function, and we're going to demonstrate that in the next couple slides. Okay, so here they give us the relation. It is -4, 2, which they have actually graphed wrong. So I'm going to fix it real quick. I'm going to put it in red. -4, 2. So -4 is here, and 2 is right there. So it should be there. And then we have 6, 1, a -1. So really, that's out here. I'm just going to put it right there. Let's see. So that point would be right there. 0, 0 would be right here. -4, 0 would be right here. And then pi squared, it's going to be, it's around in here. All right. So don't look at the blue dots, look at the red dots for this. And they want to know, is this relation a function? And again, you want to do your vertical line test. So you can kind of use the lines on the graph to help you. Your vertical line test, if you take your pencil and you hold it straight up and down and you lay it on your graph and you run it across your graph, what you're looking for is that pencil, the edge, the leading edge of that pencil cannot touch two parts of the graph at any one time. Now, if I look here, if my pencil was here and I drew it in, if it goes down there, if you notice right now, my pencil is touching both points here. So that means that this relation is not a function. It only has to happen once, and then it makes it not a function. Okay, so here we have another graph, and we're looking, is this relation a function? So again, take your pencil, hold it straight up and down, like sit it on your desk, straight up and down. So that's vertical. And then I want you to take it and lay it on your graph. And you're not looking at the thickness of the pencil, but the leading edge. As you drag it across the graph from left to right, like you read a page in a book, I want you to look, and does that pencil ever touch more than one part of the graph at a time? And if you notice, like if my pencil stops right here, so if I draw my pencil in there, how many parts of the graph am I touching? I'm touching here, I'm touching here, I'm touching here. So that means that this graph is touching, on the vertical line test at one point, my pencil is touching 3 points of the graph. So that means that this is not a function because it fails the vertical line test. All right, let's take a look at our parabola here. And if I lay my pencil down, and again, I go across from left to right, and I look at the leading edge. This one, it gets a little hard because it's a little steep, but at no point, if I were to draw in some vertical lines here, at no point, again, they're not going to be perfectly straight, but at no point does my pencil touch more than one part of the graphed parabola at once. So this parabola is a function. Now, one of the things that they're going to ask you guys, I'm going to erase this part real quick, is on Hawks, when they do this, they're going to give you an equation, ask you to graph it, or ask you if it's a function. And if it is, they're going to ask you to give the domain and the range. So remember before we talked about your domain, it's the set of all x values. So what we're going to look at here is, what x values could we put into this parabola to make it work? Now, this parabola, it's only graphed on a little part of the graph, but remember, your parabola keeps going out. It's going to keep going up and out. So your domain for this parabola, for any parabola that opens up or down, your domain is always going to be all real numbers, because this line keeps going up and out. Anywhere on this line, I can pick an x value and I'll have a y value. So my domain, when we write it, and they may ask it for an interval notation, it would be negative infinity to positive infinity. Now the range, that's your y values. So it's where is it covered, where's the graph, I'll switch to red here, where is the graph on the y-axis? If you look at this graph, it's on the y-axis all the way until we get to, right down here. And now again, this one is not perfect on the graph, but I'm going to estimate this is its lowest point right here. So I'm going to say my range, and then it goes up there and it will go on infinitely because we have those arrows. I'm going to say my range, because it's going to include it, we'll do the bracket. I'm going to estimate it again. Negative 1.5. Yours should be better than that. They should have definite answers all the way to infinity. And again, that's a bracket there. Sorry for the bad drawing. Because it includes negative 1.5 and then it goes all the way to infinity, and we always put parentheses there. All right, so here they are giving us an equation with x and y variables. And they're telling us it represents a function, so they're telling us it passes the vertical line test. And they want us to rewrite each one so that y is a function of x. When they say this, y is a function of x, what they mean is they want it to be y equals, and then evaluate that function at -3. So the first thing you have to do is solve this equation here for y equals. So we are going to, let's see, we'll add 1. I want to get y by itself. Oh, that's 1, not y. Geez Louise. Let me erase that. All right, let's add 1. So now I have 7x plus 4 is equal to 2y. And now we're going to divide everything by 2. So I will have y equals 7/2 x plus 2. And I just moved the y over to the other side. Now, because we are writing it as a function, we've made it y equals, but to show that it's a function, we are going to add in our function notation, which is the crazy looking, it's f of x, or f with the x in parentheses, equals 7/2 x plus 2. So we've written it as a function of x. Now we need to evaluate the function at x equals -3. So the first thing we're going to do, or what we're going to do is, what they're looking for is they're looking for f of -3. We're evaluating it at -3, which means we're plugging in the -3 into our equation. So I'm going to have 7/2, and instead of x, I'll put in my -3, and then add 2. So f of -3, when I multiply, remember you can put a 1 underneath, so 7 times -3 is -21. 2 times 1 is 2, plus positive 2. And then what I want to do is I want to make them both into fractions. I think it'll be easier. So remember, 2, I need a denominator of 2. So I have -21 over 2 plus, and then my 2. If I make it have a denominator of 2, started off as 2 over 1. So I multiplied that, the bottom by 2. I'm going to multiply the top by 2 and make it 4 over 2. So -21 over 2 plus 4 over 2 gives me -17 over 2. So f of -3, when I evaluate it, is equal to -17 over 2. Okay, so now we have b, and again, we're going to write it as a function of x, so we're going to make it y equals. So this one is pretty simplistic in that nature. We just have to add 5 to both sides. So I'll have y equals x squared plus 5. And then if I write it as a function, it's f of x, which just means this is function notation. So it's a function of x at x squared plus 5. And whenever you see this notation, you can know that it's already been proven to be a function. It passes the vertical line test. And then they ask us to evaluate the function at f of -3, or x is -3. So f of -3 means, again, where x is, I'm going to plug in -3. So I'll do -3 squared plus 5. And that is going to give me -3 squared is 9. 9 plus 5 is 14. So f of -3 equals 14. Okay, so here is our last one that we need to solve for y, excuse me, and then evaluate at x equals -3. So the first thing I'm going to do is I'm going to treat this radical as one expression. I'm going to move that whole thing over. So I'm going to subtract the square root of 1 minus x from both sides. And that is going to end up, give me -2y is equal to 6 minus the square root of 1 minus x. I still need to get y by itself, so I'm going to divide everything by -2, each term, and that radical is one term. So that will give me y equals -3, and then, because 6 divided by -2 is a -3, and then the two negatives here, negative square root 1 minus x and -2, make that a positive square root 1 minus x all over 2. And then again, the final thing you can do to make it into a function is take that y equals, and instead of y, make it f of x. All right, and then the last thing we need to do is evaluate that function at x equals -3. So I'm going to say f of -3 equals -3 plus the square root of 1 minus -3, because I plug in my -3, all divided by 2, or divided by 2. So that is going to mean that we're going to have -3 plus 1 minus -3 under my radical will be plus a positive, so it becomes the square root of 4 divided by 2, or -3 plus the square root of 4 is 2. 2 divided by 2 is 1, so we get -3 plus 1, and my answer is going to be -2. So f of x evaluated at -3, when I plug -3 in for x, my final answer gives me -2 for this equation. Okay, so here, again, we still have some functions that they gave us, and we are going to evaluate those functions for the given values within our parentheses. So our parent function, or the function they gave us, the original one, is f of x equals 3x squared minus 2. And for a, they want us to find f of a. And again, remember, whatever is in this little thing is what you plug into your function, where the variable is. So for this first one, it's going to seem kind of simplistic and kind of crazy, but all they want is, instead of x, we're going to do 3 times a squared minus 2. And that's all we're doing. That is it for that equation. So my answer to f of a is just 3a squared minus 2. I can't do any more because it is not, like, we can't simplify it. Now for b, they want f of x plus h. So that means wherever there's an x, I have to plug in x plus h. In this case, it's 3x squared, so I have to make that x plus h squared minus 2. And we can simplify this. So if I go to do that, I have 3 times x plus h. And remember, if you square an expression, you got to write it twice. Don't go to math jail. And then we're going to multiply it. Now, when you multiply 2 numbers at a time, or 2 terms. So I could do 3 times x plus h, or I could do x plus h times x plus h and then distribute the 3. Either way, you get the same answer. I'm going to go ahead and do 3 times x plus h. So I'll have 3x plus 3h, which I now have to multiply times x plus h minus 2. So to do that, I think I'm going to move it up here where I have more space. All right, so when we FOIL, 3x times x is 3x squared. 3x times h is going to be 3xh. And then we'll do the inside. So 3h times x, and I'm going to keep my variables in the same order. It will be plus 3xh. And then my last two, 3h times h will be plus 3h squared. We can combine like terms. So I'm going to have 3x squared plus, I'll combine these two, 6xh plus 3h squared. And then don't forget we had that minus 2 there, so I'm going to tack that on. And I can't do anything else with that. So f of x plus h is equal to 3x squared plus 6xh plus 3h squared minus 2. And again, there aren't any like terms here, so I can't combine it anymore, but I can leave it just like that. All right, so our last one, we're still using the same function as before, 3x squared minus 2. But now we're going to do f of x plus h minus f of x, all divided by h. So, and this, for some of you, you may see later on, it's really your difference quotient. They don't introduce it like that here, but that's what we're doing. If you recall from the other page, I'm not going to make us do it over again, but f of x plus h, we did that already, and it was equal to 3x squared plus 6xh plus 3h squared minus 2. Okay. So I'm going to plug that into my equation here. So we're going to have different parts. So I'm going to put my 3x squared plus 6xh plus 3h squared minus 2, because that takes care of that. And then I have to do minus, and again, because I'm putting in an expression, I'm going to put parentheses there, f of x. So I'm going to put the original equation in. So minus 3x squared minus 2. Okay, over, all over h. So when I combine like terms here, remember, you distribute that negative, so that becomes a negative 3 and a positive 2. So that means that my 3x squareds are going to cancel and my 2's are going to cancel. So right now I have this. I have 6xh plus 3h squared over h. Now, some of you are like, well, can we simplify and pull out like an h? We can, but we cannot just cancel our h's right now, because remember, then you would be busting up a family. Excuse me, and we don't do that. We don't bust up families, but we can factor this top and then pull out an h if we can. So they both have an h, and they actually both have a greatest common factor of 3. So I'm going to factor out 3h, which will give me 2x plus h here, all divided by h. And now, because it's a part of a factor, we can get rid of our h's. So our final answer is 3 times 2x plus h, or if you distribute 6x plus 3h, and that would be our final answer there. It's a little cumbersome, but it does work. You just have to make sure you, have the right signs and follow all the steps. All right, and the last thing that we're going to do here is we are going to look at the domain of the following functions. So again, the domain is your x values. What can we use for x? And with most functions, most of the time your domain is going to be all x, all real numbers, all x, any number. The only time you have to be concerned when you're looking at a function that they give you and they want to know the domain is when you have two things. One, a radical, or a fraction. So that's what we're going to look at now. So let's look at A. All right, so for A, to find the domain, the 5x doesn't matter because I can put anything in there and we'll get a value out of it. I can times it by 0, I get 0, which is a number. I can times it by -1, get -5. But remember, with a radical, if it's a square root, and again, it's not for square roots or fourth roots, underneath a radical, if it's a square root, what number can you never have, or what kind of numbers? Unless we deal with complex numbers, we can't have negative numbers. So what we need to do here is we basically have to figure out, because we have an x here, we have to figure out, well, what numbers can I plug in that won't give me a negative number under that radical and make the whole expression undefined or not a real solution. So whenever you have a radical, what you're going to do is you want to take that radical. So I'm going to take just the radical, the square root of 3 minus x. I'm not going to worry about the minus sign in front of it. And I basically need to solve that equation. I need to say, well, this radical needs to be greater than or equal to 0. So whatever number I plug in has to be greater than or equal to 0. So now we can get rid of our radical. To do that, square both sides, which if you square 0, you get 0. So we have 3 minus x is greater than or equal to 0. So to solve it, I'll subtract 3. And now I have the opposite of x, or negative x, is greater than or equal to negative 3. But I want to make it positive, so I'm going to divide by negative 1. Remember, when you divide by a negative and you have an inequality, you have to flip your sign. So my domain here says that x can be less than or equal to 3. What it's saying is I can plug any number into this equation that is smaller than or equal to 3. Any other type of number, if it's greater than 3, will give me a negative under the radical, and it won't work. So when they ask you to write your domain, what I would do is, since x is less than or equal to 3, is put it in interval notation. So I would say negative infinity to 3, and 3 would have a bracket because it includes 3. All right, now, when you have a fraction, the big thing that we worry about are what do we know about fractions and what do we not like in our denominator? You're right, we can't have 0 in our denominator. So whenever I have a function where there's a variable in the denominator, what you have to do is basically you have to say, well, what values will make this equation true and what values will turn that bottom number into a 0. And if you get a 0 on the bottom, it won't work. So you take whatever your denominator is, and it's only the denominator that you're worried about. I don't care about the numerator, doesn't matter. But we're going to take the x squared minus 1 and set it equal to 0. Basically, we have to solve this equation, figure out when it would be equal to 0. Now, this is the difference of perfect squares. It's a quadratic, so I have to factor it. So when I factor it, it would be x plus 1 times x minus 1 equals 0. And then I'm going to set them both to 0 to solve. And I know that when x is, or to equal 0, x would have to be negative 1 or positive 1. So what it's telling me here is I can plug anything into this equation except when I will get a 0 is when x is negative 1 or 1. So that means I can't use those two values. That's when my domain is undefined. That's when I will get a 0. Now, if they ask you to write this in interval notation, it's going to be a little tricky, but x cannot be negative 1 or 1. So it can be any number smaller than negative 1. So we can go negative infinity to negative 1. And we're going to put our union. We have to show it can be any number between negative 1 and 1. So what we're going to do is using our parentheses so it doesn't include negative 1 and 1. We're going to do any number between those two. And then it can be any number greater than 1. So we'll do another union and then 1 to positive infinity. So that one, again, because it was a quadratic, it's a little more involved and it has, a longer answer. But that would be how you would write it in interval notation.